So I remember saying something about well, the group that is most likely to become obese here is group A. And it's because of two things: the high amount of fats and the high amount of carbohydrates. Now, fat is a given because we usually associate eating fats with becoming fat. But that's not 100% true. If you eat the right amount of fats and the healthy types of fats, you can, not become obese. But carbohydrates is like a silent killer. The reason is this: everybody needs energy. So you usually eat carbohydrates, like you might eat bread, you might eat cassava, yam. These things have a lot of carbohydrates in it. But when you eat too much carbohydrates, now your body can store some of the excess carbohydrates. It can. But if you eat too much carbohydrates and your body cannot store the extra carbohydrates, the excess carbohydrates just get turned into fat. Your body will actually take the carbohydrates and convert it into fat and store it as fat. So that's the reason I wanted an explanation of why too much carbohydrates can lead to obesity. Right? But you had to mention the fact that, hey, excess carbohydrates, your body has a mechanism to convert it into fat and then store that fat. Right? So give my answer a read, right? And I'll be switching slides in about 20 seconds. The question has changed. It's D part 3 now. Other than diet and exercise, suggest one factor that could contribute to obesity, right? No, obviously, they kind of phrase this bad, right? They mean other than a lack of dieting and a lack of exercise, right? If you lack those two things in your lifestyle, it can lead to what? Obesity. But let's say somebody has a good diet and they do exercise. And I show everyone here knows someone like this. Like, they don't eat terrible food. They have a pretty decent diet. And every day you see them running up and down, exercising, but they are still quite overweight. Why is that? Give me one reason for that. It's just a one-word answer or a short sentence. So for this one, well, a good one. Well, even though I did put lack of sleep, right? I explained that one, right? So a lot of people might be overweight because of what? Genetics, right? Now I'm gonna delete piece of my answer here. Some people just have genetics, meaning that they might naturally have a slow metabolism. Metabolism is how fast your body can burn calories, right? Now, some people just naturally have a slow metabolism. So even though they're dieting good and they're exercising, it's really difficult for them to lose weight. And it's not impossible, but they will have a harder time. Now, I said I did not want to include this answer, the one of lack of what? Physical activity and sleep and whatnot, right? Because that's kind of tied in with your diet. So I'll just want to blank off that one, right? The person might have a certain medical condition, right? So these medical conditions usually lead to what? Weight gain. Polycystic ovary syndrome, that's commonly called PCOS. That's the same thing here. The P, cystic, that's the C, the O, and the S. PCOS. Or diabetes what? 2. Or hypothyroidism. That's when something is wrong with your thyroid. And because something is wrong with your thyroid, it slows down your metabolism. And a lot of people suffer from hypothyroidism. This means that you're going to have a very slow metabolism. Metabolism. Anybody want to tell me the opposite of hypothyroidism? Like, what type of oism will make you have a fast metabolism. And people who have the fast metabolism will actually be underweight because your body burns calories fast, 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 fast. And the person is usually underweight. So what's the opposite of hypothyroidism? Right, Zaria, correct. The opposite of hypothyroidism is hyper. So you replace the word hypo with hyperthyroidism. And a person like that, like I mentioned just now, will have a very fast metabolism, right? Also, medications like antidepressants cause people to what? Lose weight. Now, I should not mention a sedentary lifestyle because this indicates or suggests that the person does not what? Exercise a lot. A person with this type of lifestyle is just like a couch potato, right? But they said other than diet and exercise. So I should also not include this. All right. Let's move on to the next question. Right. So this here, it's we did the skeletal system, I believe, only about a month and a half ago. So send your answers for this one on the chat, please. This one, right? But to me, they were already saying the spongy bone, right? Whenever you see dots like this, that's usually the spongy part. And the compact bone will be before the spongy part. Right, so guys, if you got it wrong, don't feel too bad. It's really not your fault. It's a horrible diagram they gave you. All right. Right, but I trust that when you look at your notes, you will see something with the words spongy bone and compact bone. Part 2 suggests one benefit of bones being hollow rather than solid. Now, a lot of people think bones are solid. Bones are not solid. Look at it. Look, I'm going to circle a few things here. You all notice bones have like small openings in it. It's almost like a honeybee or a honeycomb, right? You know, when you cut a honeycomb, it just have little indents in it and whatnot. Also, the middle of your bone has a big hole in it. It has a cavity in it. Bones are not solid. What's one advantage of bones not just being one solid piece of material? Have plenty space in it. The reason is one benefit of bones being hollowed and solid, it allows for the reduction in weight. If your bones were purely solid, you would be way, way heavier. Now, you'll probably be saying, but what's the advantage of having a lighter body? If your overall weight is smaller, won't you be able to run faster? And running fast is very crucial for survival. Well, not now, right? But when we were cavemen and whatnot, to outrun predators and whatnot, you needed to be as light as possible. If your bone structure is too heavy, you're not going to be able to outrun the tigers, the saber-tooth tigers, the mammoths, right? And we've all been dead by now. Also, think about this. If your bones were too heavy by being solid, would you be able to swim? Because there are some animals whose bones are so dense and don't have enough spaces in it. The animals are too heavy. So when you push them in water, it's impossible for them to swim, right? So having hollow bones allows us to run faster, move faster, and it allows us to be able to have the ability to swim, right? Right, so something is blocking part B here, right? Let's go. Name 2 raw materials required for the process of photosynthesis and one product of photosynthesis, right? For photosynthesis, plants, this is something plants do, right? This is how plants make their food. Plants will take carbon dioxide from the atmosphere and take water, well, from the soil. It will mix these two together. And then it will produce two things. Glucose, which is better known as plant food. Yes, plants need glucose, just like how animals need glucose. All living things need glucose to get energy. And it also produces what? Oxygen, right? So this is a pretty simple one, right? I'm not going to spend too much time on this. Let's move on. Oh, Lord, I gave away the answer for this one. I forgot to hide the answer. So anyway, Cindy, destarches. Destarch just means you remove all the starch from a leaf. But let me talk about this thing. Remember, we just spoke about something called photosynthesis. So here we have a leaf, right? I'll do my best to draw a leaf here. We now said plants will take two things. Plants take carbon dioxide. I put in CO2, that's a symbol for carbon dioxide. And it also takes what? Water. So carbon dioxide and water will enter the leaf of a plant. Plants have a very, very special part of it called the chloroplast, which contains something called chlorophyll. The point is, when the plant mixes these two in the leaves, you get two things. And we just saw the plant will make glucose and it will also make what? Oxygen. The glucose is used in respiration. Remember, for respiration to take place, because plants need energy. But the plants will take the glucose to make what? Energy. Quick question. In the human body, right? If you have too much glucose, what does your body do with the extra glucose? I mentioned it about 5 minutes ago. If you eat too much glucose, so you have too much glucose in your body, keep in mind, ask yourself, where does glucose come from? Remember, glucose comes from carbohydrates, foods like bread and cassava and whatnot. So when you eat too much carbohydrates, you end up with too much glucose. What happens to the extra glucose in the human body? Right, Caitlin, correct. The extra glucose is converted into fat. Remember, we said that not too long ago. Plants have a similar mechanism. If a plant has too much glucose, it doesn't store the extra glucose as fat, but it will convert the extra glucose into something called starch. Anybody wants to give me an example of what type of food, plant food obviously, has a lot of starch? What food do we eat contains a lot of starch? Just two examples. No, I talk about plants. What two plants that we eat contain a lot of starch? Ah, Nika, correct. The potato. Potato is a starchy food. What about cassava? Right? What about, well, sweet potatoes, obviously. Well, what about dasheen? I'm not too sure if I can spell dasheen, but I was going to assume that's how you spell it, right? You see, these types of plants are really good at converting glucose to starch. Don't get me wrong, sometimes starch is stored in the leaves of the plant, but some plants have so much starch, they send the extra starch down to the roots of the plant, like dasheen and cassava and potatoes, right? So I just wanted to mention that, right? Beans have some starch in it, but beans are mostly known for their protein content. Okay, beans do have some starch, but they're more known for the proteins, right? So apparently, Cindy took this leaf that had some starch stored in it, and she removed all the starch from the leaf, right? I'm going to use this word here. How much people know what a variegated leaf is? Right. Now, I didn't know either because this is, I mean, I've never seen this word on the syllabus. So when I was doing the past paper, I was like, hey, what is that? Nobody never tell me what that is. Anybody ever saw these plants at home? Probably your grandmother have them or your parents might have them. And it has a leaf, but the leaf is two colors. It is be a piece of the leaf, this be green, and then piece of the leaf, this be kind of yellow. It's a kind of funny looking plant. I'm sorry I didn't copy and paste a picture. Anybody ever see that leaf by the parents' house? It has two colors. It's kind of yellow and green at the same time. It's more for decorative purposes. That is what a variegated leaf is. All right. So remember also, starch is used in the lab, right? Sorry, iodine is used in the lab to test for starch, right? I want everyone to find a note on testing for starch in your notes. Turn back and let me know when you find it. Here. Let's say you have a beaker, a glass container, and we put a type of food that has starch in it. So let's say we take some cassava and we chop it up because cassava contains a lot of starch. So now we're going to take this chemical called iodine. So we're going to take a test tube of iodine. The color of iodine is this. It's literally almost this color, a kind of darkish yellow color, right? Let me put a little arrow here. Iodine. When iodine is thrown into starch, if there's really starch here, it will turn into a kind of dark blue. The starch will turn to dark blue. But that is only if there is starch present. If Cindy took out all the starch from the leaf, do you think the iodine is going to change color from yellowish to blue? No, it's not going to change what? Color. Also, I have no idea, right? Why this question is so easy, right? Look at the amount of marks here, 4 marks. And all we're required to know here is that iodine turns blue in the presence of starch. So the examiner is giving away marks there. Just literally giving away marks. All right, so everyone understands that one? Let me know. And I want to move on to the next question. Right, so good. This one here is like, I say, let's call this again, when one animal eats the other animal, a food web, right? A food chain, sorry. Right? Have a primary producers. So let me explain what a primary producer is. Primary producers are basically plants, okay? Plants produce, at the bottom of the food chain is plants because animals need to eat plants like cows and whatnot. And then carnivores will eat what? The herbivores, right? So whenever at the bottom of the food chain is usually primary producers. Now they're asking for the one that has the greatest biomass. If we took all the plants, now I know a lot of people said the jaguar, right? Now, don't get me wrong. Let's pay attention to the word mass or how heavy it is. Let us go keep it simple. I know a jaguar is heavier than a plant. So let me say we have a plant here, like a tomato plant or whatnot, right? Any sort of plant. Grass is a plant also, obviously. A jaguar is heavier than a plant. So naturally, a lot of people say the jaguar has the greatest amount of biomass. But they said the group of organisms, if I took all the plants in the world and took all the jaguars in the world, or even all the animals in the world, like all the top predators, right? Which one you think will weigh more? Won't the plants weigh more? Plants greatly, greatly outnumber the amount of animals on the planet. And there's a very, very, very good reason for that. What do plants depend on to make food? What two things plants need to make food? Plants just need sunlight, carbon dioxide, and what's the third thing? Water. So for plants to make food, they only need three things. But guess what? It have plenty sunlight. The sun is be shining for half the day, right? It always have carbon dioxide around, and water is pretty abundant on Earth. That is why there are so many plants on Earth. Now, other animals depend on plants, right? Like small, like which ones here? Like the macaw and the fruit bats and some insects will depend on plants, right? Now, there's a good reason as we go up the food chain, the amount of animals on Earth or organisms gets less. Let's just take the insects and compare it to the parrot. Which one it obviously has more? You notice the parrot is a little bit higher and the insects are a little bit lower on the food chain. Obviously, if we count up the amount of insects on Earth, it's going to greatly outnumber the amount of parrots. In your backyard, I sure it have over 1,000,000, literally 1,000,000 ants, and I just ants alone. Here the reason for it, right? The more energy or resources available for an organism, the more it will multiply on Earth. Let me put this in a situation like this. Let's say that you just come out the bank. So a few hours pass. Let me say a few hours pass. And you took out $1,000 from the ATM machine or from the bank or whatever. And then a bandit comes. So this is supposed to be the bandit here, right? With this little, right? He has a little knife here and whatnot, right? Now, a few hours have passed. When it comes to rob you, right? Or even say a day or two pass, do you think he will get $1,000 from you? And let's just say that the 1,000, you gave him all the money you had on him on that particular day you got robbed. Do you think after a few hours or after a few days, the bandit, when he robs you, do you think he will get a full $1,000 from you? Well, what's his short answer to that? The answer is no, right? Most likely, he would only get $100, 1/10 or 10% of your money. And there's a reason I chose 10%. Because when you got that $1,000, you need to live. For all you know, you buy some KFC, you pay your tea and tech bill, you pay what? Your water bill, right? You pay, I know you pay this, you pay your internet bill. You probably pay that first before you even pay for your KFC, because internet is life. So to live, you need a certain amount of money. It's only what is remaining the bandit will what? Get. I want you to think of energy like money. Energy is usually measured in joules, right? Remember, energy, you get it from glucose, right? So an organism may have 1,000 joules. They may eat 1,000 joules in food, right? But when the organism above them in the food chain eats them, the organism doesn't get 1,000 joules. The organism above will only get 10% of the energy. So as you go up the food chain, the amount of energy available to the predator on top gets less and less and less. In fact, the plants may start off with 1,000,000 joules of energy, right? That's not a million, one more zero is required, right? Plants, like when an organism, the amount of energy stored in a lot of plants may be what, 1,000,000 joules. But by the time the insects get to eat those plants, they will not get the full 1,000,000 joules. They might only get what? 100,000 joules, 1/10. Then when the macaw or the parrot eats the insects, the parrot doesn't get the full 1,000 joules because these insects need to live, they need to perform respiration. They will use the majority of energy to live, and the only thing remaining in their bodies after, at the point of being eaten, is 1/10 of that. So you'll get 10,000 joules. And by the time the jaguar eats the parrot, he only gets 1,000 joules. You notice up here how much energy was available? Only 1,000 joules. So if an organism is at the top of the food chain, is only getting 1,000 joules, do you think there will be plenty of that organism living? No. They need more energy in order to do what? Multiply. The lack of energy prevents them from multiplying too much, right? So what is the role of the primary producers, the plants? They convert energy from sunlight, right? Plants need sun, into organic compounds through the process called photosynthesis. Organic compounds is like glucose. Glucose is an example of an organic compound. Explain why subsistence tropic levels, right, possesses less energy. Let me just simplify this. The tropic level is each level here as we go up. The plant is one level, insects, then the parrot. And I showed you that the amount of energy is getting less and less and less. The reason for that, the organisms is using up the energy just to live, right? Read my answer, right? And I want you to take down this one. I want you to, in fact, do me a favor, right? Take down this, the answer, what, this is a primary producer example, what? Plants. And this is what plants do in a food chain. And then I want you to take down this question, and I want you to take down my answer for it. Because I don't believe, I'm not too sure. I could have done this in September. I'm not too sure, but just in case, take it down. Let me know when you are finished. Try this question here. Suggest one consequence of parrots being removed. All right, so let's say somebody removes the parrot. So they kill all the parrots on planet Earth for whatever reason. So the planet is now, okay, the parrot is now an extinct species. Which animals do you think will be affected by this? Right? The parrot has been removed. Do you think the jaguars will eat less or more now? Do you think the vampire bats will eat less or more now? Do you think the pythons will eat less or more? No, okay, I think some of you are misinterpreting this question. All right. Suppose one day, right? Let's say you are a python, right? Who depends on the parrot for food. You notice the arrow going towards the python. Or so the jaguar too. So let's play it as a jaguar, because you have a picture of the jaguar here. The jaguar depends on the parrot. So every morning it wakes up, he says, oh, I hope I get a parrot to eat today, right? Or a monkey to eat. But all the parrots have disappeared. So there's less food available for the jaguar now because he used to feast on parrots. So the jaguar is going to eat less. So over time, do you think that the jaguar population will increase or decrease? It will decrease because the jaguar is now what? Sad, right? That's a sad face there. Right? He has less to eat. So his population over time is going to drop. But even though the jaguar is sad, guess who happy? The insects, right? Because the parrots used to eat the insects. So the cockroaches and the spiders, and spiders not an insect, right? But the crickets and the grasshoppers, they are happy because there are less people to eat them now. So do you think their population will increase or decrease? I'm talking about the insects. If there's less people, I mean not less people, sorry, less animals eating them, do you think their population will increase or decrease? It's definitely going to what? Increase. So you see how removing one animal from the food chain can cause disruptions on both ends, above and below. When you remove an animal, usually one animal will be happy and usually one animal will be sad. Okay, so let me summarize that answer. They just ask you for one consequence. I chose to go with the insects. The amount of insects will increase. Obviously, you could have said the amount of jaguars will decrease. You could have also said the amount of pythons would decrease. Right. Oh, we just finished question 2. All right, guys, now we're close to the end of class right now. I know current cutoff today, right? So what I'm going to do, I'm going to organize both recordings, the recording before class cutoff and this recording. And I'm going to send it to everybody on the group chat, okay? And also remember, next week, Saturday, there is no class, right? And this Wednesday, I'm making up the HSB and integrated science class at 6:45. Full reminders will be sent.